All right, so get this. Today, we're diving into some pretty wild research. And, well, it all starts with the Mona Lisa.
The Mona Lisa.
Yeah, you heard that right. And here's the kicker. It's all tied to, get this, cholesterol research.
Okay, now I'm really intrigued. You got to tell me more.
Oh, we will. We're going to unpack some really fascinating research that was just published in Communications Biology.
Oh, cool.
It's from researchers at the Medical University of South Carolina. And they might have stumbled onto a whole new way to treat high cholesterol, specifically a genetic condition called familial hypercholesterolemia.
You mean FH?
Yeah, exactly, FH.
It's actually a lot more common than people think, and it could be, pretty rough for those who have it.
So let's start with the Mona Lisa connection. How on earth did this all begin with a 500-year-old painting?
Well, there's this theory, it's been kind of floating around among art historians, that Lisa del Giocondo, the woman thought to be the model for the Mona Lisa, might have had FH. Yeah, and they point to those, those little fatty deposits. You can kind of see them around her eyes and on her hands in the painting.
Huh, never noticed those before.
They're called xanthomas.
Xanthomas, okay.
Of course, we can't, actually diagnose someone from 500 years ago just from a painting, but, it does make you wonder, right?
Yeah, it definitely raises some eyebrows.
Yeah.
So speaking of FH, can you give us a little, cholesterol 101? What exactly is FH, and what makes it different from just having, a little high cholesterol?
So FH, it's genetic. You inherit a mutation in a gene called LDLR.
Okay.
And this gene is what makes the LDLR protein, which is think of it like a tiny little vacuum cleaner in your cells that scoops up LDL cholesterol, the bad kind, and gets it out of your bloodstream.
Got it. So the bad cholesterol.
Right. But with FH, either you don't have enough of these little vacuum cleaners or they just don't work.
Oh, I see.
So even if someone with FH is eating healthy and exercising, their LDL can still be dangerously high.
Makes sense. So that's where this new research comes in. They're trying to find a way to, fix those broken vacuums.
Not quite, actually. That's what's so cool about this study.
Oh.
The usual treatment for high cholesterol is statins, right?
Yeah.
And those work by kind of boosting the activity of the existing LDLR proteins.
Okay.
But for a lot of folks with FH, especially those with a severe form called homozygous FH, statins aren't super effective.
Homozygous FH.
Yeah, that's where the LDLR gene is basically totally out of commission.
So the statins are trying to boost something that's not even there.
Pretty much. It's like trying to start a car with a dead battery.
So what did these researchers do differently? How they approach this problem?
They went old school in a way. They had this library of over 3,000 different chemical compounds.
That was a lot.
Right. And they basically tested each one to see if it could lower cholesterol in, get this, human liver cells they'd grown in the lab.
Wait, hold up. They grew human liver cells in the lab. How is that even possible?
Stem cells.
Oh, right, stem cells.
It's this incredible technique called induced pluripotent stem cell technology, or iPSC for short.
iPSC.
Basically, you take adult cells, like skin cells, and reprogram them to become any type of cell you want, even liver cells.
So they basically built a mini liver in a dish.
You got it. And they were specifically looking for compounds that could lower the amount of something called apolipoprotein B, or apoB, being produced by these liver cells.
apoB. What's that?
Think of it like the packaging for LDL cholesterol.
Packaging.
Yeah. It's what lets those cholesterol particles travel in the bloodstream.
Oh, that's interesting.
So the thinking was, if you can lower apoB, you lower LDL cholesterol.
Smart. So they weren't going after the LDLR protein at all. They were targeting the packaging instead.
Exactly. And guess what? They actually found a whole group of molecules that were super effective at doing just that.
Wow. So they basically stumbled onto a new treatment pathway just by trying a bunch of stuff. That's pretty cool.
It is cool, but of course it wasn't all smooth sailing. There was a bit of a hiccup along the way.
Oh no, what happened?
So naturally, the next step was to test their best compounds in mice, right? See if they could really bring down those cholesterol levels.
Yeah, makes sense.
But here's the twist. Nothing happened. The compounds were totally ineffective in the mice.
Oh, that's a bummer. What went wrong?
Well, it turns out mouse livers are just a little bit different from human livers, at least when it comes to how they process certain molecules.
So something that works great in human liver cells might not do a thing in a mouse.
Exactly, which is why they needed to get a little more creative. They needed a living organism that was, more human-like for testing.
Okay, so what do they do? Go back to the drawing board.
Not exactly. They turned to something called avatar mice.
Avatar mice. Like the movie.
It does sound a bit sci-fi, right? But essentially, these mice have livers that are mostly made up of human liver cells.
Whoa, hold on. So they basically gave these mice humanized livers.
Yeah, pretty wild, huh? And it turned out to be a stroke of genius because when they tested the compounds in these avatar mice, they finally saw what they were hoping for. The apoB and LDL cholesterol levels dropped significantly.
So even though the regular mouse experiments failed, they found a workaround and showed that their approach could actually work in a living being.
Exactly. And it just goes to show how important it is to use human-relevant models in research, Animals are essential, but sometimes you need something that's a closer match to human biology to really get the full picture.
I see. So they found this whole new way to lower cholesterol, one that doesn't rely on the LDLR pathway at all.
Yep. Which is a potential game changer, especially for those folks with homozygous FH who don't respond well to statins.
I can definitely see why this is such a big deal. But, and maybe this is a silly question, if they started this whole thing without really knowing how these compounds work, do they have a better understanding now? Like, what's the mechanism?
That is the million-dollar question. And that's where the next phase of research comes in. They know these compounds work, but the how is still a bit of a mystery.
Okay, so more work to be done.
Oh, yeah, plenty. But figuring out that how, the mechanism, could lead to even more targeted and effective treatments down the road.
This is all so fascinating. It seems like every step of the way they hit a roadblock, but they just kept finding creative solutions and pushing forward.
That's science for you. And to think, it all started with a simple observation about a painting. Who knew the Mona Lisa could hold a clue to a potential breakthrough in cholesterol treatment?
It's amazing where inspiration can come from.
Yeah, isn't it?
Okay, we've covered a lot here. Art history, stem cells, avatar mice, and a potential new treatment for a serious genetic condition. We're going to need a minute to process all of this.
Yeah.
So we've seen how these researchers, kind of went off the beaten path to find these new cholesterol-lowering compounds. But what does this all actually mean for, real people living with FH?
Well, if these compounds, actually pan out in clinical trials, we could be looking at a major breakthrough for people with FH, especially those with the homozygous form who don't really respond to statins.
That's got to be so frustrating for them, to know there are treatments out there, but they don't work for their specific situation.
Oh, absolutely. Imagine living with this constant threat of high cholesterol, knowing it puts you at risk for heart disease, and then having limited treatment options. It's got to be incredibly discouraging.
So this new treatment could offer them some real hope, not just in terms of actually lowering their cholesterol, but also just, improving their quality of life.
Exactly. It could mean fewer worries, less restrictive diets and more freedom to just live their lives without FH constantly looming over them.
And considering how common FH is, it affects something like 1 in 200 people. The impact of this new treatment could be huge.
Oh, absolutely. We're potentially talking about millions of people worldwide who could benefit from this.
That's incredible. But it's not just about the number of people impacted, right? What about the cost of treatment? FH often requires, lifelong medication and monitoring, which can be a real financial burden.
That's a really important point. If this new treatment turns out to be not only effective, but also more affordable, it could really, really reduce the financial strain on individuals and healthcare systems.
So this research has the potential to be a real game changer on multiple fronts.
Yeah, it really does. But beyond the immediate impact on FH treatment, this research also has some pretty big implications for the future of drug discovery and personalized medicine as a whole.
Oh, I was hoping we'd get into that. You mentioned earlier that this study is a prime example of personalized medicine in action. Can you kind of break that down for us?
Sure. So traditionally, drugs have been developed with, the average patient in mind, kind of a one-size-fits-all approach. But as we've seen with FH, everyone's genetic makeup is unique, and what works for one person might not work for another.
So personalized medicine is about moving away from that one-size-fits-all model and tailoring treatments to the individual.
Exactly. And this study really shows how powerful that approach can be. By using iPSC technology to create liver cells with the specific genetic defect that causes FH, they were able to develop a treatment that directly targets that defect, something that wouldn't have been possible using, those traditional methods.
It's like they created a custom-made solution for a very specific problem.
That's a great analogy. And this kind of personalized approach, it has the potential to revolutionize how we treat a whole bunch of diseases, not just FH.
So this research could could pave the way for like a whole new era of medicine where treatments are tailored to each individual's genetic makeup.
Precisely. Imagine a future where we can, predict a person's risk for certain diseases and develop personalized prevention strategies or create medications that are specifically designed to work with their unique biology.
That sounds like something straight out of like a science fiction movie. But is this really feasible? I mean, isn't personalized medicine still like years away?
It's definitely still early days, but the progress being made in fields like, genomics and stem cell research is really remarkable. I mean, just a few decades ago, the idea of reprogramming adult cells into stem cells seemed like pure fantasy, and now it's a routine procedure in labs all over the world.
So you're saying that what seems impossible today, could be commonplace tomorrow.
Exactly. And the study on FH is just one example of the incredible strides being made. We're seeing similar breakthroughs in cancer research, rare diseases, and even in understanding how our genes influence how we respond to different medications.
That's all really exciting. But I also have to ask, are there any like potential downsides to this personalized approach? It sounds almost too good to be true.
It's a good question, and it's important to acknowledge that any new technology comes with, its own set of challenges. One major concern with personalized medicine is the issue of accessibility. We need to make sure that these treatments are available to everyone who needs them, not just, those who can afford them.
That's a really critical point. It wouldn't be much progress if these, groundbreaking treatments were only available to a select few.
Absolutely. Equity and access are paramount. Another important consideration is data privacy and security. Personalized medicine relies heavily on collecting and analyzing vast amounts of genetic information.
So we need to be sure that this information is handled responsibly and used ethically.
Precisely. We need to strike a balance between, advancing scientific progress and protecting individual rights.
It's a reminder that with any great scientific leap forward, there come ethical considerations that need to be addressed.
Exactly. And it's a conversation we need to have as a society.
Yeah.
We need to weigh the potential benefits against the potential risks and ensure that these new technologies are used in a way that benefits everyone.
Okay, so we've gone from the Mona Lisa to avatar mice to the future of medicine. Where do we go from here?
Well, I think the key takeaway is that we're at a pivotal moment in healthcare. Personalized medicine is no longer a distant dream. It's becoming a reality, and this research on FH is a powerful example of what's possible.
So what are the next steps? Where do you think the researchers will focus their efforts in the coming years?
Well, first and foremost, we need to see how these new compounds perform in human clinical trials. That's the gold standard for determining whether a treatment is truly safe and effective.
So we need to move beyond the lab and see how these compounds work in real people.
Exactly. And assuming the clinical trials are successful, researchers will then focus on fine-tuning the treatment, optimizing dosage regimens, and exploring potential combination therapies.
I'm thinking back to your earlier point about combining this new approach with existing treatments like statins. Mm-hmm. Could that be a possibility?
Absolutely. Since these new compounds work, independently of the LDLR pathway, they could potentially be used alongside statins to create a more comprehensive treatment strategy for FH. It's a really exciting avenue for future research.
It sounds like there's a lot of work ahead, but also a lot of potential for improving the lives of people with FH?
It's a truly fascinating time to be in this field. The pace of discovery is accelerating, and we're constantly pushing the boundaries of what's possible in medicine.
Okay, before we wrap up, I want to go back to something you mentioned earlier about the potential for personalized medicine to revolutionize how we treat other diseases.
Yeah.
Beyond FH, what other areas are you particularly excited about?
Well, one area that holds immense promise is cancer treatment. We're already seeing personalized approaches being used to identify specific genetic mutations in tumors, which allows for more targeted and effective therapies.
So instead of using like a blanket approach to treating cancer, doctors can now tailor treatments to the specific characteristics of each patient's tumor.
Exactly. And this is just the tip of the iceberg. We're also seeing personalized approaches being used in the treatment of rare diseases, infectious diseases, and even mental health conditions. The possibilities are truly endless.
It's amazing to think that we're on the verge of a new era in medicine where treatments are no longer one size fits all, but tailored to the individual.
It's an incredibly exciting time, and this research on FH is a testament to the power of human ingenuity and the potential of personalized medicine to transform healthcare as we know it.
Okay, well, we've covered a lot of ground today, from art history to cutting edge science to the future of medicine. Before we sign off, I want to leave our listener with a final thought-provoking question to ponder.
Sounds intriguing. What do you have in mind?
Well, we've seen how personalized medicine can be used to treat diseases, but what about using it to prevent them in the first place? Imagine a future where we can, analyze a person's genetic information and identify their predisposition for certain conditions, allowing us to intervene early and potentially prevent those diseases from ever developing.
That's a fascinating concept, and it's certainly within the realm of possibility as our understanding of genetics and disease mechanisms continues to grow. We may one day be able to predict a person's risk for a wide range of conditions and develop personalized prevention strategies.
It's a powerful idea, and one that raises all sorts of ethical and societal questions. But if we can harness the power of personalized medicine responsibly, it could revolutionize not just how we treat diseases, but also how we approach healthcare as a whole.
It's a future worth striving for, one where healthcare is proactive rather than reactive, preventative rather than curative.
Okay, we've delved deep into the world of cholesterol research and explored the vast potential of personalized medicine, but as always, our journey doesn't end here. We encourage you to keep learning, keep questioning, and keep pushing the boundaries of what's possible in healthcare. Yeah, it's kind of mind-blowing to think we could actually be on the verge of preventing diseases before they even start.
It really speaks to the transformative power of personalized medicine, right? I mean, we've been talking about treatment, but the possibilities for prevention are just as exciting, if not more so.
It's like instead of fighting fires, we're stopping them from even happening in the first place.
Exactly. Imagine being able to identify people who are at high risk for certain conditions, and then, stepping in early, maybe making some lifestyle changes, maybe some early intervention, and just completely changing the course of their health.
It would be revolutionary for public health, right?
Yeah.
I mean, we could potentially see fewer cases of all these chronic diseases, heart disease, cancer, diabetes. That would mean countless lives saved and just a healthier population overall.
And it's not just about living longer. It's about living well. It's about extending health span, not just lifespan.
That's a really good point. We tend to focus on adding years to life, but what really matters is adding life to those years.
Absolutely. And personalized medicine, it has the potential to do just that.
But like you said earlier, there are some big questions we need to grapple with as we enter this new era of medicine, especially around things like access and equity.
You're absolutely right. These technologies, they can't just be for the privileged few. We have to make sure that everyone benefits from these advances, regardless of their socioeconomic background or where they live.
It's a critical point, right? I mean, we don't want to create a healthcare system where only the wealthy can afford to prevent diseases, while others are left behind.
Exactly. Access to personalized medicine, it has to be equitable. It has to be inclusive.
And then there's the whole issue of data privacy and security, right? I mean, we're talking about incredibly sensitive information here, people's genetic blueprints. We have to make sure that data is protected and used responsibly.
Absolutely. Data security and privacy, those are non-negotiables. We need strong safeguards in place to prevent any kind of misuse or discrimination based on genetic information.
It's a complex issue for sure, but one that we absolutely have to address head on if we really want to realize the full potential of personalized medicine.
You're right. It's a collective responsibility. It involves scientists, it involves policymakers, healthcare providers, and the public. We all have a role to play.
So that it's not just about about developing the technology. It's about creating the ethical and societal framework to actually use it wisely.
Precisely. We need to have these open and honest conversations about the implications of personalized medicine and make sure that it's used in a way that benefits all of us, that benefits humanity.
This has been quite a journey. We started with a curious clue in the Mona Lisa and ended up exploring the future of medicine.
It's amazing how a single painting can spark such a wide-ranging conversation about science and innovation and the potential for a healthier future for everyone.
So as we wrap up this deep dive, what's the one key takeaway you want to leave our listener with?
I think the most important message is that personalized medicine it's not some far off fantasy. It's happening now, and it has the potential to completely change healthcare in ways we can't even fully imagine yet.
It's a powerful reminder that the future of medicine isn't set in stone. It's being shaped by the choices we're making right now, today.
And those choices, they need to be guided by a commitment to scientific rigor, to ethical considerations, and to a vision of healthcare that is truly equitable and accessible for everyone.
So to our listener out there, we encourage you to stay curious, stay informed, and engage in the conversations that are gonna shape the future of health and well-being.
Remember, the future isn't something that just happens to us. It's something we create together.
And with that, we'll bring this deep dive to a close. We hope you've enjoyed exploring this fascinating world of personalized medicine and the incredible possibilities it holds for the future.
Until next time, stay curious and keep exploring.